Nice job with this one. I'll just walk you through what you did so you can see it written out. 8 factorial, you just did 8 times 7 times 6 times 5, blah, blah. You got that. Perfect. Evaluate 7 factorial over 7 minus 2 factorial. So you said that was 7 factorial over 5 factorial. So when you did 7 factorial over 5 factorial, you just started to write out 7 times 6, and then you realized that the 5 factorial would cancel out with the 5 factorial down there, and you did 7 times 6 is 42. Perfect. For number 2, in terms of factorials, 8p3, that's your formula, looking gorgeous. So you have 8 factorial over 8 minus 3 is 5 factorial. You started writing out 8 factorial as 8 times 7 times 6, and then you realized that the 5 factorial would cancel out with the 5 factorial down there. So 8 times 7 times 6 gave you 336. Perfect. Here, now you've got your formula for combinations, n factorial over n minus r factorial, starting out just like the permutations, but with an extra r factorial. So you did 8 factorial over 8 minus 3 was 5 factorial times an extra 3 factorial. And when you started to write that out, I'll do it again down here, you have 8 factorial over 5 factorial times 3 factorial. And you started to write out 8 times 7 times 6, and then you realized the 5 factorial would cancel out with the 5 factorial down there. But you still have the 3 factorial, 3 times 2 times 1. And then you can start to cancel out this stuff. So the 5 factorials cancel, the 3, take out a 3 to give you 2, divide by 2, divide by 2. So 4 times 7 times 2 gave you 56. And again, the whole bottom should go away when you do these, leaving only stuff on the top. So perfect. For number 4, Chess Club is looking for a way to select a president, a treasurer, and a secretary. How many ways can these positions be filled? So you care about the order because you have a president, a treasurer, and a secretary. If you just were selecting 3 committee members and just 3 people to be in a committee and they didn't have titles, then it wouldn't matter what order you picked them in. But here it does. So you chose permutations. 20 people, you want to arrange 3 of them. Plugging them into your formula. 20 factorial over 20 minus 3 is 17 factorial. You started to write out 20 factorial until you realized the 17 factorial would cancel with the 17 factorial down there. And 20 times 19 times 18 gave you that. Perfect. This one here, in how many different ways can the letters of Kissimmee be arranged? There are 9 letters in there. So you said 9 factorial, and some of them are repeats. So you have 2 I's, 2 S's, 2 M's, and 2 E's. So there's 2 I's, 2 S's, 2 M's, and 2 E's. So perfect setup, and that equals, you just did 9 factorial over 2 times 2 times 2 times 2 times 2. And here you just did, okay, I know that that's 2 times 1 times 2 times 1 times 2 times 1 times 2 times 1, which is 16. You just did that divided by 16, and you got that. Perfect. This last one down here, oh wait, she gave you minus a half for that one. Wonder why. Let's check it on the calculator. The work looks fine. So if I do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I get 3,62880, and then 2, 4, 8, 16. So if I divide by 16, I get 22680. Something just must have went kablooey on your calculator when you did that. That's too bad, because this work is perfect. The final answer should just be 22680. So 22680, 22680 for your final. It's the only tiny mistake, just a calculator mistake on that one. here you've got an ice cream parlor, has 23 flavors. He orders a banana split and has to select from 3 different flavors. How many selections are possible? Now here you don't care what order you choose your flavors in. You could put on strawberry and then chocolate and then vanilla, or vanilla, chocolate, and strawberry. He doesn't care, he just wants to eat it. So there are 23 flavors to choose from. He's going to choose 3. So you've got your formula, plugging and chugging, 23 factorial over 20 factorial times an extra 3 factorial. You started to write out the 23 factorial until you realized that the 20 factorials would cancel, but you would still have the 3 times 2 times 1 on the bottom. And you start to cancel out some of that, or it looks like you just multiply the top, multiply the bottom, and divided. That works too. Perfect. Nice job.